Okay, in this lecture we work through some Jupyter Notebook examples on how to do the p-test that we talked about in the previous uh, examples, previous lecture. And so we began by doing our imports. Okay, I'm going to import from NumPy the absolute value, the square root, the mean, the standard deviation, and this random package because I'm going to do a sample. And then from SciPy stats, I'm going to import the norm because I'm going to be using it to calculate our CDF for the normal distribution. For this, I'm going to set the significance at 0.01, and I'm going to say we have a mu naught value of 95. Okay, and so we begin with the two-tailed test, and for the two-tailed test I'm going to have to define three functions. And I'd better start entering my cells or I'll get a bad surprise later. Okay, now I need three functions to do my two-tailed test. The first is two-tailed test stat, which I'll be calculating my test statistic. This is the same one we've done before: mu naught, x bar, standard deviation, and sample size. And it had one line in it. I calculate the standard error of the mean. If I were willing to have uglier code, I could work this in and we could have it all in the return function. I could just roll this in for this part right here. But as it is, I think it's easier to read where I take the absolute value of the z-score of this with the standard error of the mean as a single variable in the denominator. Okay, now the two-tailed p-value. I'll enter the test statistic, and I will return 2 times 1 minus the norm dot CDF of the test statistic. Okay, and finally my criterion to reject, and that I'll be able to use this this function in all parts of all the tests I do today. I'm going to say reject if the p-value is less than the significance. So I can treat my function like a question. It says reject, and then if it returns true, yes, I reject. If it returns false, then I do not reject. So I shift and I enter. That's now entered into my notebook. I'm going to take a sample now. Now that I have my basically my test criterion set, I'm going to take a sample and recall my mu naught was 95 back here. Well, I'm going to sample a uniform distribution from 90 to 100. So this should have a mean, the uniform risk distribution does have a mean of 95. When I sample from it, it should be pretty close to 95. I'll take the standard deviation, and then using the information I've had so far, I'll run compute my two-tailed test statistic, and then I will calculate the p-value. Okay, now I'll say, well, do I reject reject this? And quite frankly, I don't know. There's always, I think that we won't reject, but there's always a some chance that we will. And so false. Okay, we don't reject this time. Now, all of these calculations were done inside a black box. Okay, I'd like to know some of the values that we worked with, and so I'll check out on x bar and the test statistic and the p-value. I shift and I enter. Well, x bar is 95.26, so it's not exactly 95. We would be shocked if it were exactly 95. It's fairly close. The test statistic here is pretty small, but our p-value is huge. Okay, p-values are always going to be less than 1 because they're probabilities. This was more than half, guys. So yeah, we reject. So is 0.5 less than 0.02? Oh hell no, it's not. So false. Okay, now let's do a right-tailed test. That H naught is mu is less than or equal to mu naught. HA is mu is greater than or equal to mu naught. Here, okay, I'll define the one-tailed test statistic, and I'll be able to use this for my left tail as well, because all I'm doing is taking the z-score here, right, with my standard error of the mean as my standard deviation. Now my right tail p-value, it's 1 minus norm.cdf of this test statistics. So I shift, I enter, okay, those are in, and now I do the same thing. Now this time, okay, I want to stack the deck. Okay, I'm setting the sample size to be 55. I'm leaving mu naught set at 95, but this time I'm going to sample from a uniform distribution between 100 and 110. The mean of this is 105, so when I take my x bar, that should be close to 105. Okay, do the standard deviation and then calculate the one-tailed test stat of this with all of the right variables plugged in, and calculate the p-value. And I shift. Okay. Shift and enter. And okay, and didn't produce anything, but then I shift and enter, and true, it rejects it. Well, it should have rejected it, okay, because it's getting x bar is going to be up around 105, and I'm testing it against 95. It's just a huge difference. In order to show you this, I'm going to insert a cell below and show you the type of values that I'm getting. X bar, that should be about 95. A test statistic, my TS, and then my P value. P underscore value. Shift and enter, and yep, about 105. My test statistic was 25, and the P value is 0, because there's no probability that this is going to happen. Finally, the left-tailed test, and because of the order I've done things in, this has the least functions to set up. I just have to find my left tail p-value because I use the same reject as I do for all of them, and I do the same test statistic as I did for the right tail. So this again returns norm.cdf of the test statistic. It's a very simple function. Okay, and here again I get this will reject here if this is too if my x bar is too small. Okay, but let's choose here. I'm sampling from the interval from 94 to 95, so this is going to be close to 95. It'll be 94.5. I'll take my x bar, my standard deviation, okay, and then my test statistic, one-tailed test, do that calculation, calculate the p-value, And then do I reject it? This one I'm not quite sure, but true, I will reject it. Now, what is the p-value? P-value. Okay, well, sure enough, this is around 94.5. The test statistic is like negative 8.9. And, okay, golly, this p-value is 1.32. Okay, but e minus 19, that means times 10 to the negative 19th power. So yeah, a very small p-value, and so we do reject.